Hi there, this is Mr. Hall. This is a really quick video about chromatography and a focus on the results. I've already made a video about the method. I focused on how you set it up, the key pitfalls and errors that can happen with chromatography methods and how the whole process works. This video is much more about what you do with the results once you have the whole thing completed. Now this basically breaks down into two different areas. Okay, the first area that we're going to be discussing today is how you interpret chromatograms qualitatively, how you describe the pattern of chromatogram in comparison to others. The second thing I'll be talking about is RF values, which is a specific type of calculation that you need to be able to do. They're quite straightforward, but you do need to know how to do them. All right, so first off, let's talk about how you interpret these chromatograms. Now, the chromatograms that you're going to get are probably going to be very different to what you have experienced in school or in the lab, wherever you've been working up to this point. What you probably would have got is a nice spectrum of colour for your unknown. So your unknown may contain like yellow and red and whatever it may be, and it will be like a spectrum of color. So the yellow bit might last for several centimeters, and the red might do the same, and so on. It won't be discrete dots, not really anyway. Now in exam questions, analyzing real chromatograms is actually quite hard. So what you are going to be given instead is one with specific dots, which makes it a lot easier to analyze. So there are three things you have to do when you're interpreting these chromatograms. First off, you need to say how many dyes are in a substance and in comparison to others. You need to be able to say which substances contain the same dyes as those in known substances. And you also need to say which substances contain dyes not found in other substances. Now that all seems a little bit abstract, so it's probably better for us to go through it with a worked example. So as you can see here, this is typical of what you might get in an exam style question. Notice that there are discrete dots rather than the spectrum that you might get in the real thing. So we've got suite A and we've got suite B with stuff in it that we need to work out what it is. And we've also got the known dyes and their chromatograms for dye X, dye Y, and dye Z. So the best way of going through it is a worked example. So let's kind of go through what we have. So we've got suite A and suite B. Now the first question is, well, the first thing we have to do is how many dyes are present in a substance and in comparison to others. Now if we look at suite A, now suite A has 1, 2, 3 different substances. So the first thing we have to say is that it's got 3 substances. I'm just going to write 3 sub, just because I'm being a bit lazy. And then if you look at suite B has got 1, 2, 3, and 4. So here I'm just going to write B, and this has got 4 substances. Okay, that's the first thing we do. We also have to say in comparison to others. Now this is something which is quite nice. So we can see that A has got 3, B has got 4, so B has 1 more than A. So it's always quite nice to also say B has 1 more than A. Okay, that's the first thing we do, okay, and that'll bag you a couple of marks. Now the second bit is which substances contain the same dyes as those in known substances. Okay, so what we're going to do is we're going to look at A and see which of these 3 are also lining up with X, Y, and Z, because then we can literally identify what they are. So if we look at this first dot, it lines up with this one, which is dye X. We know that that is X. If we look at this one, that actually doesn't line up with any of them. Okay, so I'm just going to put a question mark and we'll come back to that later. If you look at the bottom one, this lines up with dye Y, which is there. Okay, so going back to this question, I'm actually going to write up here now. For A, it contains X and Y. Okay. And yeah, so let's tidy up this Y here to make it a bit clearer. All right, now let's have a look at the same thing for B. Now B also contains dye X. Now it also contains these 2. Now these 2, if you look across, doesn't line up with any of the others. So I'm just going to put a question mark next to those 2. This one also lines up with that one, so it also contains dye Y. Okay, so what we're also going to say is B contains X and Y. Oh, there we go. And that's basically how you do it. So that's the first thing. So we've said which substances contain the same dyes as those in those substances. We've done that. Now the final thing we have to do is we have to identify dyes which are not found in other substances. So now there's 2 basically angles you can do this. The first thing is we can mention the dyes which don't line up with any of the known dyes. So we can say A contains 1 unknown dye, okay, which is in reference to this one over here. B also contains 2 which are unknown, so we can write a similar sentence saying B contains 2 unknown dyes. Okay, there's a couple of ways you can phrase that. You could say unknown dyes, you could say dyes which are not found in X, Y, or Z. The other thing you could also say is you could identify the fact that Z is not in any of them as well. So we could also write, we're going to write this down here, Z not in A or B. All right, so that is effectively how you analyze chromatograms. The best thing of doing it, in my opinion, is to follow that structure and almost has it like a bullet point. So, first bullet point, A contains 3 dyes, B contains 4 dyes, B has 1 more dye, and then your next bullet point is saying which of the known dyes are in the suite, and the next one which are missing. So if you do it in a systematic way, you're very, very likely to pick up all the marks. And to be honest, it's a very straightforward 3 or 4 marks you're going to get, but if you follow a tight structure, you're not going to get it wrong. The fun thing I just want to mention is about RF values. Now, RF values are actually very, very straightforward. To calculate the RF value, you have to divide the distance moved by an individual spot by the distance moved by the solvent. Now, you're likely to get this either in a diagram form in an exam question or in a table. Either way, it's the same calculation. So let's have a look at our old chromatogram, which is here, which I had in my previous video. Now, we've got a red dot, we've got a yellow dot, we've got a green dot. Now, let's say that the solvent moved a total of 8 centimeters. And the individual dots moved, 7 centimeters for the green, yellow moved 3, and the red moved 1. So each of those individual dots, you can calculate its own individual RF value. So to do that, if we do it for green, first of all, I'm just going to write G here. So first of all, I'll do the distance moved by the spot, which in this case is 7. So I'll do 7, and then divide by 8, and that will give me my RF value. Okay, I haven't got a calculator at hand, but that's how you do it. And then for the yellow, same thing. The distance moved by the spot in this case is 3. So it'll be 3 divided by 8, which gives you a number. And then for the red dot, it's going to be 1 divided by 8, which again gives you another RF value. So I'm actually going to spend a second just calculating these because it's worth actually analysing the numbers that come out. So for the green, it's 7 divided by 8, which gives you 0.875. For the yellow, it's 3 divided by 8, which is 0.375. And then finally for the red, it's 1 over 8, which is 0.125. A couple of things worth mentioning about your RF values. Number one, they are always numbers less than 1. Okay, they're always going to be decimals. Now that kind of makes sense because it's impossible for one of your dyes or colours to go beyond the solvent front. The solvent front will always be the highest number. So you're always going to get a decimal, like 0 point something. If you get a number bigger than 1, you know that you've made a mistake, start again or rethink it, okay, in the exam. Really, really important. The second thing to mention is that the higher the dot travels, the closer your RF value approaches 1, which again makes sense because the closer it goes up, the closer it's near the solvent front, which means it's closer to the value of 1, if you like. So that's something worth mentioning as well. So as we go from green to yellow to red, you can see it goes from 0.875 to 0.375 and to 0.125. So it's progressively getting smaller the closer you're going to that pencil line. Okay, so that's how you calculate RF values. And that's it. Well, I hope this video has been helpful and best luck with your chromatography questions.